series that will help you stay relevant in the age of knowledge automation, either because it will convince you of the irreplaceability of human intelligence, or because it will teach you how to use narrow AI and convince an investor that you're actually building super intelligence. This is episode 3, Science Reality versus Silicon Valley Fiction. This video will explain why AI is not conscious, what's a probabilistic machine, and why LLMs are a sort of parrot. Why AI is just algorithms plus data and statistics, and what can AI be actually used to do effectively. This episode will give you a lot of practical advice on how to stay relevant, how to push back on hype and bullshit, how to embrace the useful tools, and how to tell them apart, and also how to ignore it altogether and stay sane in the age of everything automation. First question, is AI conscious? As I mentioned in the first video, one of the biggest existential worries with AI is whether it can become autonomous agents, no pun intended, well actually kind of a little bit of pun intended, but not in the sense of agents, that's what I mean. And this has famously been the plots of books like I, Robot, that later became a movie, and other movies like Terminator, although I don't recommend going beyond Terminator 2, and The Matrix. In the case of The Matrix, not only were computers autonomous and self-interested, but they were also able to simulate a reality in which humans were put into and were blissfully ignorant of being dominated by machines. So chatbots are the first step to self-awareness, maybe, and the answer to that question is really no. And I don't think it's absolutely impossible to build intelligent machines, but I do know that we lack understanding of what actual intelligence is to really be able to recreate it. And at the same time, we know exactly what chatbots are doing. We might not know exactly how precisely language is encoded in neural network connections, so on and so forth, but we know exactly what mathematical operations are being performed when they are doing what they're doing, or where they're producing the output that they produce. So as for a general kind of intelligence, we may not even know the kind of math that is required to do that. We might, and that's assuming that math can get us there if we know it, if that's not something completely non-mathematical or something completely unknown to us so far. It's great that Turing and Shannon took interest in recreating intelligence back there in the 50s, but there's a gulf between worthy research programs and actually achieving their objectives. And it's usually a good thing to be scientifically ambitious. If a research program is well structured, its results will be worthwhile, even if it doesn't achieve its ultimate goal. That's how science works. You set something up, and in trying to do something, you learn about what you didn't know. You learn about what you didn't even know that you didn't know in the first place. So even if the behavior of some of these systems seems intelligent, that's because they're helpful, not because they're actually conscious and think about problems in any way analogous to what humans do. What happens under the hood are very well-defined mathematical operations, and we know how that works. And I think we're mostly past the AI hype theater 3000, as some people call it, that we saw a couple of years ago with the release of ChatGPT, and even Sam Altman, the CEO or something, chairman, whatever it is, of OpenAI, main guy, I don't know. He gave up on selling AGI or super intelligence and saying he was building that a few investment cycles ago. And nevertheless, some of these ideas of AGI and general intelligence, super intelligence, AI being conscious, so on and so forth, they persist and they stick around. And there's this idea that if people just scale up and improve these technologies, the current technologies as they are enough, we'll arrive at something that is conscious and able to interact with humans at the same intellectual level. The flip side to that question is, are LLMs just stochastic parrots? In the completely opposite camp to the conscious LLM one, there are the ones who say that there's really nothing to LLMs, that they're just parrots. Full disclosure, I identify more with this camp than with the conscious LLM one. And nevertheless, I worry a bit that their arguments are not as nuanced to recognize the benefits of LLM. Even if these benefits are not justified by the cost, their impact on the planet, the public at this point are used to not worrying about the impact, and we're not going to get into that because it's a completely different dimension of AI and its development. Anyway, to this camp, LLMs are just stochastic parrots. You may have heard this definition before, but in case you haven't, stochastic just means probabilistic or random. So stochastic parrots are supposed to mean that they're basically LLMs basically repeat words out of a list in some context, picking at random words with some probability that be more likely in that context. Another way of putting this is that LLMs are like autocomplete on overdrive. That's what they would be to this camp. So give or take some technical stuff, and that's like indeed true, but it doesn't make them useless. What it means is that we need to be aware of their limitations and what they can do and what they cannot. And for instance, not mistake useful output for expert advice, for instance. A slightly harsher definition of them is that they're bullshit machines. And that's not like hating on LLMs necessarily. It's actually based on a philosophical definition of bullshit. I won't get into this right now, I'll get into it later, but it means that LLMs don't have any commitment to truth. They certainly, like, you have certainly heard CTOs and CEOs talking about these chatbots like hallucinating, but another way of describing the same phenomenon is to say that they're actually bullshitting. They're producing bullshit. And if you like use that argument and someone complains, you can actually say that you're being like philosophically formal about LLMs and not just hating them or calling them bullshitters. So here's what I think is a critical, nuanced picture of using these concepts and about LLMs, in my opinion. So I think large language models are good at putting together like useful, realistic sounding text, but they do so in a similar way to your phone's autocomplete. In an improved method, yes, but there's no magic or consciousness really there. So they randomly insert words that have high probability of following your prompt and following each word that they put there before. And in that way, they end up finding through the data that they had useful answers one way or another. Because that's probabilistic and there's no check for the output being true, you may get words or sentences that don't make sense at some point or are flat out like wrong. If you can work with that and you can like say what's good and what's bad, that's great. But don't count on it for like accurate legal, medical, or relationship advice, because you may end up like broke, dead of a heart attack, or even worse, like brokenhearted in your relationship. I like to define not only LLMs, but artificial intelligence in general by debuzzing the words in it. So it goes something like this. Artificial intelligence is just machine learning, which is just statistical modeling, which is just algorithms that has replaced some part of the instructions with data and a statistical model. Data that was generated by humans and a statistical model developed by the humans. So as I already explained, AI is like a broad generic term that can be anything from a series of if-else statements and like switch statements like in a decision tree, all the way to like a deep neural network with sophisticated attention modules, attention heads and mechanisms, that's the technical term. And the latter is the kind of thing that people are thinking when AI said these days is a chat bot that can interact with you. But whatever case you pick, whatever specific concrete AI application you pick, machine learning will be a better term for what it's doing. And machine learning is the same exact math as statistical modeling. The practice may differ a bit, but there's nothing really that you do in machine learning that is not a part of statistical modeling. And that's a whole argument, but I won't go there either. But if you're a statistical modeler, you just pick up things in machine learning, like the practices, and you're good to go. That's just the reality. And the final step, which kind of converts this kind of symbolic AI algorithms as such into statistical AI, is by getting like an algorithm in the 20th century sense, which is just a series of instructions and code that automates simple commands and take some part of it that you couldn't possibly code by hand, all the statements from first principles, so that you have an intelligent behavior or intelligent seeming behavior more specifically, and you replace that with a statistical model. And then you put a bunch of data so that you can inform these parameters, and you estimate the parameters, you get the best fit, and you put an interface to interact with that model. So what we get is AI is basically an algorithm with data and statistics in it. That's breaking down the first statement that I made in the beginning of this passage, that AI is just machine learning, is just statistical modeling, is just algorithms with data and statistics. In to give an example, like even simpler than that, in the 60s, Joseph Weizenbaum, a German-American scientist at MIT, developed a therapist chatbot in an IBM 7090, which is like one of the first transistor computers. Its CPU was like 10 times slower than the first personal computer that I ever had access to at home. It was like an IBM 286 that could even run the first Windows that had color in it, Windows 3.1. And it was wouldn't matter because the screen was black and white anyway. It was my father's computer, wasn't even mine, of course. And this IBM 790 was literally like over 1,000 times slower than an average chip CPU that we have these days. And if you think LLMs are convincing, you should look it up. It's called ELIZA with a Z. And I think you'll be surprised with how realistic and convincing it can be, considering there's like very little actual code to it. There's like very simple algorithm that you could run in those computers, no neural network, no data, no nothing. And if you replace these naive instructions of basically looking up a keyword and spitting back like a very simple sentence with this huge statistical model with billions, possibly trillions of parameters estimated from text with trillions of words, what you get is a modern LLM. So no intelligence either, just much more sophisticated processing of the text. Look it up, look ELIZA. If you have Emacs, if you have a terminal, you can just do meta x and doctor, and it'll show up there. If you can also look it online like ELIZA and just type something there, and it's kind of fun. So yeah, check that out. So what does AI's intelligence help with? What is it useful for? And spoiler alert, it's good for like narrow tasks. We mentioned like many definitions, and they do matter. There's a huge existential difference whether an AI application is conscious or is just like a statistical parrot, or if they're a bullshitting script written in the 60s that even my washing machine can run with the CPU it has in there, like a tiny thing. But that's like a theoretical and philosophical important as well issue, and we can know exactly which one the chatbots that we have is the one with like the virtual feathers. So it's important globally, but we know which one it actually is. So in practice, what really matters is what we can do with them. Can I fire a programmer or a designer and replace it with ChatGPT? Of course not, because ChatGPT won't drive itself to work and talk to a client or log into a Zoom call or something. Can I replace them with like an AI agent? Technically possible, but yeah, good luck with that. It might delete your code base or database, or it might send like an offensive picture to the CEO of a company that's a client of yours. And I doubt like anyone would really let an agent run amok and do things unsupervised and that require accountability, because computers have like no accountability. Even IBM had a chart that said that like that said don't let a computer make a decision that I forget exactly what it said, but it said don't let a computer make a decision for which a human has to be accountable or something. I'll look it up later. But yeah, look that up, because basically you cannot make a computer accountable for a decision. A human will have to be. So in practice, you really cannot do that. So what is AI good for? And more precisely, what is machine learning good for? Machine learning is good for narrow problems. In the life sciences, for instance, where there are like models addressing the problem of predicting a 3D structure of a protein from the sequence of amino acids, and that was like, the models were okay, but they were not great. And Google's AlphaFold 2 made like a breakthrough in accurately being able to predict these structures. It didn't solve the problem completely, because proteins are not static, and it's also important to know what happens in the process of folding these proteins. You basically have a string of amino acids, and they have to be folded into a 3D structure that is often like globular. But it's also important how they fold, and they're also dynamic after that. So still, it was a big deal. It's very useful for biologists, and it won a Nobel Prize. As a parenthesis, I don't think it should have won the Nobel Prize, but I also don't think the Nobel Prize should exist. But that's besides the point. But machine learning was very effective in tackling that specific narrow problem of predicting the fold 3D structure, the folded 3D structure of proteins based on the amino acid sequences. And it did that by looking at a lot of proteins that had the sequence, where it had the sequence and the structure, as well as their evolutionary relationship. And they built a custom model that could do that. And that's great. But it's a narrow task. It's a very well-defined task. Most people won't be able to use a model that gives you a 3D structure out of amino acids, because that's not useful for everyone. Another problem that was a hard problem was speech generation and recognition. And people had worked for decades on that. My father actually worked on that problem in the 80s. Same time he had like the 286 computer. And now there's an app that can like read web articles like to me in the voice of Richard Feynman very convincingly. I think I don't know what his family thinks of that. Sometimes I think about the like ethical implications, but I guess they have copyright. I have no idea really. But I guess if they're doing it, it's legal. I hope it's a known company that does that. Anyway, but at least like when I read and actually like read with my eyes the Feynman lectures on physics, I don't have to just wonder what it sounded like. Now I'm familiar with Richard Feynman's voice, and that's pretty cool. And yeah, chatbots are impressive because natural language processing, like or NLP researchers as a community developed a way of converting language into mathematical entities, and we had good math to manipulate vectors, which is how words are encoded. But for problems like that of proteins that are already about 3D coordinates and machine learning, like they're even better because you don't have to encode something kind of subjectively or in a mathematically encoded way that will be helpful to manipulate, but is not their natural conformation. Sequence of amino acids are sequences, and 3D coordinates are 3D coordinates. So for those kinds of problems, machine learning really is an excellent tool. And for things that require more general understanding of complex situations or deep theoretical understanding of the physical or biological laws, for that, machine learning is not great, and it will probably fail, and it will probably fail badly. So yeah, bottom line, narrow problems are what machine learning models are good at, and especially narrow problems where the mathematical description is already one that is clear from the problem itself, that you don't have to transform and manipulate them in a very kind of subjective way or complex and decision dependent way. What about AGI, artificial general intelligence, the buzzword that we saw thrown around a lot, especially by OpenAI in the earlier days of ChatGPT, but also by like every other company as the holy grail of AI. So it was not about AI anymore, narrow AI. It was about AGI, some sort of general intelligence. Others would call it super intelligence, meaning the same thing, like intelligence that, like that of humans, is general and can solve like any problem. It can think about it and figure out general kind of problem and solution. It can solve any problem a human could, but it would not be limited by our human limited learning speed, learning capacity, capacity to store knowledge and be able to access it. If you don't practice it, it would just all be there. This was not a distinction that like the forefathers of the field of AI made. I believe nobody there was like, okay, let's create this crappy garden variety AI that has no actual intelligence and just works for some specific things, and let some other smart guys create artificial general intelligence, which they didn't say, in like 50 years from now, because those guys are really smart. Like we're talking about Turing, Shannon, many like amazing, famous researchers, I guess. But anyway, so this kind of intelligence would be able to read like every available text in the world and have that knowledge right there in media and video and whatever. That's not actually very hard to do. You can just load data into a computer. That's the easy part. But then it will understand all of it and at light speed generate new knowledge about any problem that we cannot solve as humans, and even generate solutions to problems we didn't even know that existed, and figure out laws that we never dreamed of even. So we could basically have it do anything for us. It could like create a moon colony, it could create a Mars colony, it can travel to Alpha Centauri, or it can like solve world hunger, find a way to make humans live forever, because it would just be able to access, if it's possible, it'll be able to put it together and at a speed of computers like lightning fast, just develop things that we would take years, decades, millennia to develop. It could also decide that we are like useless and kill us all, just like we kill like slow computer processes in our computers. And again, like Terminator, Matrix, why would it need us if it can just do anything, and it would be able to just do it much faster? We're just in the way. So humans would be disposable. So that's like the existential worry about developing technology of this sort. At least like free humans would be disposable. Maybe it could be used for energy, like in the Matrix. We are also seeing that kind of problem with regular AI that needs a lot of computing power, a lot of electricity. So that's one way that a Matrix makes a lot of sense. But yeah, AGI is as sci-fi as it was 10, 100, or 1,000 years ago. There's like nothing in the technology that we have today that points to any AI stuff becoming generally intelligence in any way, like at all. Sure, there are discussions to be had about like the consequence of even narrow AI and how it's applied, what damages it can do, how it can be useful, how it can affect humans. Sure, and there's also interesting discussions about how general form of AI may or may not be achievable. If we should do it, we should not do it. But beyond like academic, more philosophical circles, in the sense of should we do it or not, and technical ones in how we can try to do something that is not data and pattern driven to generate stochastic repetitions or variations in a way. In academic and technical circles, I haven't seen any serious discussion about this. It's mostly like hype with all sorts of other goals, like raising like investment cycles and money, whatever. I don't even know the terms for that, but it's basically selling their products, not really thinking about that. And it's mostly generated by the hype of we should do this and we can do this, we are capable, but there's nothing really pointing to that being actually possible. Summary time. This one is plain and simple, I think, kind of. You now know artificial intelligence boils down to one of many well-known probabilistic algorithms, and here are some of the take-home points for this episode. Large language models are not conscious. Maybe it's surprising how well they can make like convincing sentences with useful information, but that's mathematically very well defined. And it just means that the data contains the necessary information and that researchers got it right when trying to find a mathematical way of representing that text data. And that was an incremental process too. Like before attention model got it right, a lot of people got it wrong with like recurrent neural networks and so on. LLMs are stochastic parrots. They don't even need like trillions of parameters like to fool humans in conversation. You can look at like Eliza, the doctor therapist script from the 60s. But because they are parrots trained on terabytes of human data, they're able to like parrot quite useful sentences and quite useful information in response to many questions that we might throw at them. Language is not mathematical per se. It has to be encoded somehow, as I mentioned. That's why it's tough. AI works better in narrow problems that are already easy to formulate mathematically, and that you can have already the tools to natively manipulate the data in an efficient way. It works better in those cases because, as I mentioned, artificial intelligence is just machine learning, is just statistical modeling, is just algorithms that replace some deterministic code with explicit instructions and instead put in their probabilistic model with parameters inferred from data generated by humans. That's why it works better, and that's what AI and large language models are. This is the end of our third video on separating Silicon Valley reality from science fiction by taking a quick peek under the AI hood and seeing if there's an intelligence in there. There's not much really intelligence. There's a lot of math that there is. If you're interested in this topic particularly, and you may want to check our first flagship course, our conceptual course called From the Math to the Masses at auroracollective.io. The link is in the description, maybe in the screen around here too. We also have other courses on the math and statistics specifics of machine learning and on some other general support topics. In the next video, we're going to talk about the tech hype cycle, bullshit, and hallucinations. If you found this video useful, like and subscribe to stay in the loop. Stay cool and stay relevant.